Hi, and welcome to FCell 2.0. FCell is an exciting product that integrates .NET and Excel. Today we will demonstrate a number of impressive functionality, including writing user-defined functions, asynchronous functions, object handlers, and service-oriented architectures. Let us begin. FCell is commercially available. To get started, we need to create a new workbook like so through the FCell ribbon, which has been added to your Excel. Once we have done that, you can see that the language tools are now available. We are going to go and get started with F#. In the code editor, we can write a simple function, such as adding two numbers together. To load this, all we have to do is press the build button, and the new function is immediately available in Excel. To make a change, all we need to do is go back to the editor, make the change, and press the build button again. The spreadsheet is re-evaluated and the new value appears like so. Now let's try a more complicated function. Let's work with arrays. Here we're going to scale an array by a scalar, like so. FCell is smart enough to map the output dimensionality correctly, as you would expect, both vertically and horizontally. Now how about working with non-built-in types such as the .NET datetype? FCell automatically converts datetimes and other commonly used types so that they appear correctly in Excel. All that is needed is a little bit of formatting. You may notice here that this function is not recalculated each time we press the Calculate Now button. This is because by default, functions are not volatile. We can easily fix this by adding the Excel volatile attribute to the function. Now when we recalculate, we can see that the time has been updated. FCell has built-in extensibility, which enables user-defined types. For example, we're going to add fmat numerics library to the spreadsheet. In this spreadsheet, we have a new type called matrix. Matrix is not a built-in type for Excel or FCell. It is a new type that's being added. We're going to use this new type to do element-wise multiplication of two matrices, like so. The way we are able to allow Excel to use this type is through explicit casts that FCell is able to automatically pick up and use. Right now this functionality is embedded directly in the spreadsheet. What if we wanted to export the DLL and use it in other spreadsheets? To do this, we simply go File, Save, and save the DLL. We close the spreadsheet, create a new blank spreadsheet, which as we can see here does not yet have the user-defined function. We can reference the newly created DLL from Excel, and now all of these functions in that assembly are immediately available in this spreadsheet and every other spreadsheet we use on this computer. Now let's look at asynchronous user-defined functions. We're exposing a function here named maxFactor, which takes an n integer and returns the maximum prime factor of that integer. For large integers, this function takes a long time. When we run it normally, we can see that, annoyingly, it blocks the user interface, and there's nothing we can do at this stage but hope and wait. Using FCell, we can easily fix this problem by simply wrapping the function with an async. We can see that it no longer blocks the user interface. Let's scale up this function to a large range of integers. We can see that this function is automatically parallelized, and we are efficiently using all of the cores available on this machine. Now, what if we wanted to give the user additional feedback of the processing while it is going on? We can do this easily by composing together asynchronous and reactive programming. To push to the user interface, we are going to use F# events. We simply create an event, and whenever we find a prime, we trigger the event to all of the listeners. We create a function that uses the reactive extension scan to subscribe to the event and return the number of prime numbers found. This is particularly useful for creating real-time dashboards where the information, such as stock prices, can easily be pushed into the spreadsheet. Here we're going to demonstrate object handlers for directly using instances of complex types created in Excel. Here we have defined a new complex type for random vectors. The constructor takes in an integer n and creates a vector of n random numbers. We can then have an instance method which then calculates the average of those numbers. To do this, all we need is two static methods with the attributes xlConverter. These static methods convert between the random vector and a primitive value that is understood by Excel. In this case, we are using a string to represent the object. These conversion functions allow you to use your existing .NET types with FCell. You can see here that we are creating two instances and running the instance method mean, which needs the object handler as the first argument. So now we're going to demonstrate accessing functionality via web services, also known as service-oriented architectures. Here we are able to connect to an external web service with just a single line of code using what is called a WSDL type provider. This type provider looks up the metadata of the service and generates an API for it that is really easy to use. We can actually go to the web service and see the exposed API through the browser. This simple calculator web service exposes 4 functions: add, divide, multiply, and subtract. To use the API, we simply create an instance of the endpoint called calc and go dot And here we can see through the code completion that all of the functions are there, including the asynchronous versions of those functions. Let's try it out by adding two numbers via the web service. Now let's try it again with the asynchronous version of the same function. Finally, we are going to show you how easy it is to integrate with the ribbon. Here we can create a button from which the user can trigger a function call. Here we are triggering the function onButtonClick. This function pulls in values from the workbook type provider, which provides properties for all the named ranges in the workbook. In this case, we have the named ranges X, Y, and Z. We extract the value out of X and Y, and we use the SOA service to add the two numbers together and setting the result back into the range Z. To trigger it, we just need to press the button like so. Thank you for listening. For the latest updates, follow us on Twitter @FCellAddin and visit our website fcell.io.